What is data integrity?
Data integrity refers to the accuracy, consistency, and reliability of data stored in a database. It ensures that data remains correct and unaltered throughout its life cycle, protecting it from being lost, corrupted, or incorrectly modified. Maintaining data integrity is crucial for making reliable decisions and for ensuring trust in the systems that hold our critical information.
Why data integrity matters in databases?
Databases are the backbone of digital applications, from banking to healthcare. If data can be easily changed, lost, or corrupted, it can result in errors, security risks, or loss of business. Data integrity builds user confidence and is often required for compliance with laws and industry standards. Ultimately, strong data integrity helps organizations protect both operations and reputation.
Types of data integrity rules.
There are several key rules that help maintain data integrity. Entity integrity ensures each record is unique, often using primary keys. Referential integrity keeps relationships between tables accurate, typically through foreign keys. Domain integrity enforces valid values for fields, such as only accepting dates or positive numbers. Together, these rules ensure stored data is trustworthy and logically sound.
The role of constraints in data integrity.
The constraints are built-in enforcement tools database systems use to automatically uphold data integrity. Examples include primary keys, foreign keys, unique constraints, and checks for valid values. By applying these rules, databases can prevent accidental errors, like duplicate entries or invalid data, from being saved. Constraints reduce the need for constant manual checks and help programmers build more robust applications.
Best practices for maintaining data integrity.
Regular backups, clear data entry procedures, and security controls are also vital for data integrity. Limit user access based on roles and always validate input before storage. Use transactions to group related changes, ensuring all or none of a set of changes occur. By combining well-designed constraints with careful management and monitoring, organizations can ensure their data remains reliable and secure.